Okay. Assuming you've both started recording, let's begin. So, hey everyone, today we are doing a design and implementation session on Minimint, the Rust implementation of a federated mint. Okay, so we've got El Sirion, which is his first name is Eric, and I'll let him introduce the rest himself. So Eric, you can introduce yourself. What is Minimint? Why are you working on it? And what are the goals of the project first?
Yeah, hey, thanks for having me. And yeah, my name is Eric, and I'm like a computer scientist with a background in cryptography, distributed systems, and all the good stuff that we use in Bitcoin all the time. So yeah, and what I'm working on is a federated eCash system. And the first implementation of that is called Minimint. Also, we will be soon renaming it to Fedimint because nobody knows the distinction between Fedimint and Minimint. And it just confuses people very much. So, and yeah, what is a federated eCash system? In principle, an eCash system is a way of having like a fully private bank. Like you can give some money to some entity and the entity gives you some like anonymous representation of that money, like an IOU, which is really private. And then at a later point in time, you can redeem the IOU for your money again. And that way you can build really private transaction systems. Problem with that is so far we always had these systems be centralized. Like there was only a central party that controlled all the money, that issued these IOUs. And it would be super easy for them to just disappear with the money or be regulated. And what we're trying to do with Fedimint instead is we split up this entity into multiple parties. And as long as a certain threshold of them is honest, then the system keeps working. And so, for example, you can have 3 out of 4 Fedimint federation, and as long as no more than one of the involved federation members, we also call them guardians, is dishonest, then the federation keeps working. And as long as less than 3 of them are dishonest, then they cannot even steal money. Like there's a certain threshold for the thing keeps working and a certain threshold for someone could steal money. And these two are different. And that makes the system quite interesting, I think, because it adds a lot of resilience. And you still have all the interesting benefits of the transaction system. It's very private, it's scalable. Yeah. And we'll probably get into a lot of that later.
Yeah, great. So the Minimint project is an implementation of federated mint. That means it's a server, okay, that can talk to clients who want to make deposits, right? And it can also, yeah. I guess, and I can also it definitely cannot talk to other mints, right? So is that the structure of it? Is this we each run a server and users talk directly to any of the servers, or is there one particular one? Or yes, how does
that's a great question, actually. Yeah, first of all, like all these servers talk to each other internally. Like that's the most communication actually that happens, is these servers running a Byzantine fault tolerance protocol that makes them agree on what is happening in the system. Like essentially what we're doing is we are building a replicated state machine and we have to agree on all the state transitions. So that's what the BFT consensus is doing. And when a client wants to interact with the federation, there are multiple ways to go about it. But what we decided to do in the end is, like, for example, I want to make a transaction, then I just send a transaction to everyone, to every federation member. Like in theory, we just need to send it to at least T out of N federation members, I think. And you can calculate to how many you have to send depending on how many might be faulty. And yeah, in practice, it's close enough to just send it to everyone. That's what we do. Yeah, because like in theory, like if there's a faulty or malicious federation member, they could censor your transaction otherwise. So you have to talk to at least more than the faulty ones. And then there's also a problem, like not everyone contributes to the consensus, and the ones not contributing to the BFT consensus are not necessarily the faulty ones or the malicious ones. So you have to have some safety there. Like you need at least to talk to at least 2f+1 federation members, where f is the number of maximum faulty ones. Yeah, but in practice, just talk to all of them and see if they agree. Yeah.
Okay, so these servers are available on the web or on the internet, and you talk to them via, I think I saw as JSON RPC. Is that correct?
Yes. Currently, we talk to them via WebSockets and JSON RPC via WebSockets, and that's because we have certain events that we want to evade, like certain things that the federation has to do in the background, and it takes a bit of time. And instead of polling all the time, which is really inefficient, we just subscribe to an event via the WebSocket, and then the federation replies to the client. One interesting thing to note, because we really focus on privacy, and eventually, once this goes live, each interaction with the federation will happen through a new Tor circuit. Like, it's not implemented right now, but when you think about it, you will have to reopen a new connection for each transaction, for example, that you do. And like, the different steps of one transaction can happen through the same circuit because they are connected anyway. But once you do the next transaction, then you have to open a new circuit.
But that will create some kind of like friction in the user interface, right? Because
I think not too much, actually. Like, open a new Tor circuit isn't all that expensive, and I think the typical speed at which users,
why not just connect via Tor and like
yeah, exactly. But if you okay, the host changed. If you just connect via Tor, then whatever you do via one Tor circuit or one Tor connection can still be correlated to each other. Like, you don't have the privacy you need. Like, you actually need to create a new Tor circuit to like make two events or two interactions completely unrelated to each other. And I think that's also what Wasabi is doing.
The privacy from the federation itself for the client.
Yeah. The client wants to be also private from the federation. Actually, mainly private from the federation, because they are the ones that would otherwise be learning the most.
Mm-hmm. But when the client will be like trying to get a eCache from the federation, so that at that point, the federation will know the Bitcoin address for that client for that particular eCache that it's issuing?
Okay, maybe let's take a step back. Like, what you're describing is a deposit operation. And like, you would be depositing Bitcoin on chain to the federation, and then give the federation a proof that you just deposited Bitcoin, and they will in turn issue you eCache tokens. And in fact, yes, for such a transaction, they would know like that this Bitcoin address is related to the newly issued eCache tokens. But the great thing about how eCache tokens are issued is that at issuing time, like, everything is blinded. Like, I give a blind nonce, like a blind number that is like random pretty much, to the federation. They sign it without knowing what the actual message is they sign, and give me back a blind signature. And I can unblind both the signature and the nonce, and then I have a valid signature for a random number the federation has never seen. So when I go and spend this eCache token, which is just the nonce and signature, like this random number and the signature, then they cannot correlate it to when it was issued. But let's imagine I do both the issuing and the spending via the same connection. Then they will know, like, that's the same guy actually, like, he just kept open the same connection. So that's why we have to reopen a new connection for each operation. Mm-hmm. Yeah. Maybe I should have structured that a little bit better in the beginning, but
that's okay.
We are getting there.
Okay. Like, yeah, I got the idea. So on the other hand, like, now I got a eCache. Now I want to send that eCache to my friend. That transaction has, like, there is no way for the federation to have any visibility on that transaction, right?
It depends how you do it. Like, the really naive version of doing it is taking the eCache token, which is like just a piece of data, this nonce and the signature, and give it to your friend. And then your friend has to go to the federation and ask the federation to change it for a new eCash token, because otherwise they cannot be sure if you were double spending them. Like, okay, maybe you're friends and you don't have to do this, but generally we don't want to trust, we want to verify. And in that case, you would go to the federation, ask them to give you a new eCash token for the old one. They enter the old one into the spend book, like the list of all the spent eCash tokens, and then they receive the new one. And yeah, they couldn't really correlate anything, like who gave it to your friend or like who your friend is, because yeah, the blinding on issuing prevents them from correlating like the issue token from the spent token.
Okay, so if I get it right, so like if I have a eCash from the federation and now I gave it to my friend, now my friend needs to like convert it right away to another eCash so that we are sure that I cannot double spend it. Now, when my friend is doing that, so he's like submitting that eCash to the federation, getting a new eCash corresponding to it. At that time, does the federation know like, okay, this eCash is the one that came from Raj, or it doesn't because of the blind signature?
No, it doesn't because of the blinding. Exactly. Okay. That's the beauty of eCash. Like I only spoke about it on a very high level, but this blinding prevents the federation or the mint from correlating any transactions with each other.
Mm-hmm. Yeah, that makes sense. Another question I had on the like high level part of the like BFT system is like so the difference between the federated mint and the Chaumian mint that was like done in 1980s was like there was one company that was acting as a mint and issuing this token, and now we are trying to replace that one company with a federation, right?
Yes.
And that is that the main difference? How will you describe it, or there are more to it?
That's the main difference, really. Like having one central company is just really easy to both regulate, and like the company could also just run away with the money, like many have done before. And yeah, that's why I want to split the trust over multiple people or spread the trust. Yeah.
And how is like sorry, go ahead.
Yeah, there are other differences in the details. Like, for example, we cannot use a blind signature algorithm anymore, but have to use like a threshold blind signature algorithm. But like the semantics, when you look at the system as a whole, when you look at the federation as a whole, then it's still the same eCash system. Like just the internals, how we actually achieve these goals, they differ.
Yeah, and what would you say is like the rough numbers of like participants are like in the federation? Say like 5 people, 6 people, or can it be done by 2 people also?
That's a great question. The problem of BFT systems is, at least for like asynchronous consensus systems, that you need at least 2F plus 1 someone's trolling. Sorry. Come on.
It's the Alex with the
nigga balls.
Can you kick them? Can you kick them out, Lloyd?
Nigga balls. Niggers. Black lives doesn't matter.
Come on. Where was I?
This is why sharing the Zoom link.
This is what happens when you put the link on the Twitter, I guess.
Yeah.
Should I take it off now? I guess like people who wanted to join us already came.
Yeah, just probably best to delete the tweet about the link. Yeah. Okay, where were we?
Lloyd was speaking, but you were muted.
Yes, the other critical thing is that you can have multiple federations, right? Because it's so easy to spin them up.
Yeah, right. We were at the federation sizes. Yeah, so for these BFT consensus systems, you need at least 3F plus 1 participants, where F is the number of maximum faulty ones. And so the least number of participants that really makes sense is 4, and then you have a 3 out of 4 federation, and then you go up in steps of 3, and then the next one would be like a 5 out of 7. Next one would be like a 7 out of 10, and so on. You can do the numbers in between, but for example, if you did like a 5-member federation, it would still be a 4 out of 5. Like you can still only take a 1 offline member or 1 malicious member and not more. So it doesn't really make sense to add more participants in that sense.
What happens like when the consensus finds like someone is faulty, someone is not like doing their part properly, so the consensus kicks them out, or what's the mechanism there?
Yeah, it kind of depends. Like in our implementation right now, there's both the main consensus that we didn't touch. Like we just use a pre-made implementation of that. And I think like they are forgiving in a sense. Like I think if you begin acting correctly again, then you could participate again. But we also have some additional checks on in our implementation so that the like faulty members can stall the federation, which is really important. Like that we always make progress, and there we just ban them forever. And like if they are faulty, that means they tampered with their implementation, with the server code they are running, and so you will have to talk to them anyway. Like, what are you doing here? And like if you find out it's just a bug, then you can always fix it. But it's better to be cautious in that sense and just not let him participate anymore. But you will need to take action in that moment.
And
like the software will do it for you, but you should talk to them.
Yeah, makes sense. And do you think like in future, like there will be kind of like a marketplace for federation, like people joining up and finding each other in some portal, creating their federation and then advertising themselves in that way? How do you think like all of this is going to, like the federation part of it will come into the market?
Hey,
Yeah.
actually, sorry, can you guys hear me?
Yeah.
Yes, we can.
Okay, sorry. Actually, before we go to like this more like future how things go, can we go and look at the code? I have the code up, but actually I think it would be better if Eric pulled it up. Is it possible you could pull up your code, Eric, and we could sort of
Sure.
We could ask you about the structure of it and get into that.
Yeah. Just a moment. Where can I share screen? Here. Okay. Oh, which one of them is it? Minimint. Here we go. Can you see my screen?
Yep.
Yeah.
I saw it for a moment.
Yeah, like Zoom is weird. Like I have i3 as a desktop manager, and somehow all these Zoom overlays, they always become like full screen.
Right, cool.
Like all these little pop-ups. Okay, so you can see what's going on, right?
Yes. So first of all, what editor are you using?
That's C-Line from
C-Line.
JetBrains.
And
Yeah.
how do you find that for editing Rust?
It's very convenient because they have like their own a Rust Analyzer engine. Like they don't use Rust Analyzer, the main thing, but yeah, build their own stuff, and it's quite efficient. For a long time, it was better than Rust Analyzer, or what is it called these days? Rust Language Server.
It's called Rust Analyzer, yeah.
Rust
Okay,
Analyzer, yeah.
Used to be Rust Language Server.
Yeah. Okay, yeah, and they have a lot of refactoring tools, really good debugging tools. You can actually like graphically step through your code, which is very convenient. It doesn't always work, especially with async code. Sometimes it just gets thrown into the assembly, and then you don't really know what's going on. But like, it's a good idea, and like you have to pay for it, I think. But for me, it's totally worth it. I'm working with Rust a lot. Yeah.
Nice. I used to use the C-Line when I first started out, but then I moved to Emacs eventually. But I did appreciate the features it had back then. I'm sure they're much better. So what is the overall structure of the Minimint project? You've got quite a few different components, and these are all their own Rust crates, I guess.
Yeah, we have a workspace here.
So it's a workspace, yeah.
Yeah, like a Rust workspace, and it contains like all the different components we have. Like we could go through it. First of all, we have threshold blind signatures. It's just a little extra crate where I implemented a threshold blind signature scheme. Then we have a Lightning gateway, which is how a federation can speak to the wider Lightning network. Like it's currently a plugin for C Lightning that you can run, and then you can connect your federation with Lightning. Then Minimint, the main repository that plugs everything together. I think like it plugs together most of the following things. Minimint core, which it's kind of unfortunate that we needed. Like it's essentially what should be in Minimint, but can't be because I think the client depends on it. And yeah, like we had a few problems with cyclic dependencies, and especially we are also trying to make everything compile to WebAssembly, or like at least the client part. And so we cannot have certain dependencies in core, for example, because core compiles to WebAssembly.
Yeah, okay.
And so we split it out of Minimint. We're really bad at naming, because like I never really know what's the difference between core and API, but like core is more high level and API is more low level. Anyway, then we actually have a derive macro, which is kind of cool. Like it's the first time I built procedural macros. We use it for our encoding and decoding scheme. Like we have a custom one not using Zerde because I guess the problem with cryptographic protocols, you want to be really sure that there's only one way to encode one piece of data. Otherwise, like hashing it might become a hassle. Like you could have something supplied by the user, you hash it, then decode it, re-encode it, hash it again, and then there's a different hash, and you really want to avoid that. So we have our own binary encoding scheme.
In which case would Zerde do? I mean, obviously Zerde would do that, I guess, for JSON, or is not guaranteed to be canonical or something. But do you actually hash JSON? Is that?
No. That's why we have like the custom encoding scheme. So we have a really tight control over our binary encoding. We could use bin code, and we used it for a while. We still use it in some places, but I try to get away from it because I don't trust it really. Like Zerde is really complex.
Oh, but okay. So I was just about to ask, like, why don't you just use bin code? So you don't like bin code because you don't like deriving Zerde's serialize over it and then using bin code as the serialization format. But you know, bin code has its own it has a new version that's on like has a release candidate with its own derives. It doesn't use Zerde.
Interesting. I didn't know that.
Okay.
Like we built all the stuff quite some time ago. So yeah, the main concern was like, what if bin code breaks like backwards compatibility at some point, and like we use it to store stuff in our database, and like it's just a big hassle to rely on the dependency that's so crucial, and like building our own encoding decoding scheme. I mean, I knew it from Rust Bitcoin. That's where we do a very similar thing, and it's not that hard. Yeah. Like actually, I just copied over the encoding decoding traits from Rust Bitcoin and built some procedural macros instead of what is the other macro format called? The declarative macros, I think. Yeah. Okay, cool. Yeah, that's what the derive is for. Let's continue. Then we have a Minimint API that defines like, that's like the lowest layer of our crate hierarchy. Like I wish I had like a diagram here, like how they all depend on each other. But essentially it's Mint APIs at the bottom and all the modules depend on it.
So it has the fewest dependencies, or
yeah, exactly.
Right, cool.
Yeah, like at least inside our repository, like it's the root of everything. Yeah. Then we have a bunch of client stuff, client library, then a CLI implementation, and like experimental client D that is like long running and that you can communicate with over RPC. Then the modules, that's probably the most interesting part. Like Minimint is actually more of a framework to build federations, and it's not necessarily only a federated eCache system. Like you could build a module that makes it a federated sidechain backend, or makes it a federated marketplace or whatever. Like you could just build another module and plug it in. So that's what these three modules are for. You have the Mint module, which is for issuing the eCache tokens, the Lightning module, which connects with Lightning, and the wallet module, which holds the on-chain Bitcoin. And last but not least, we have some testing going on. And we needed a separate crate for that. I don't exactly remember why, but I think we needed some other dependencies that we didn't want to have everywhere else.
Yeah, makes sense. Yeah. Okay, so that brings us to a topic that we didn't actually cover in the high level, is the Lightning. How is the Lightning plugging into this? Right now, the thing I'm particularly interested in is right now Minimint has a fixed denomination, right? Which means that you can only deposit in a certain quantity, which is, I guess, divisible by that denomination, and withdraw with the same quantities of the same denomination. So how does that factor into the Lightning part of that?
Okay, first of all, that's more of a general problem, actually, that you only have these fixed denominations. And even if you wanted to pack out withdraw to a Bitcoin mainnet, then you don't want to only be able to withdraw certain denominations. You want to be able to withdraw any amount. Yeah. And what we actually do is, like, we probably should start from the transaction structure. Like in Minimint, each transaction has inputs, outputs, and a signature. We can ignore the signature for now, but the interesting things are inputs and outputs. And when we look at the Mint input, which is what you just described as these tokens that have a fixed amount, then in reality, it's not like one token. We call them coins here because we're inconsistent about naming. And that's like old naming scheme. Anyway, like coins is actually a map of amounts and then a list of tokens. Like you can construct any arbitrary amount from like a set of tokens. So,
I see. So each mint does different denominations.
Yeah, like each mint defines their set of denominations, and then users can use these denominations to construct arbitrary amounts. Yeah, and then, for example, a mint input would be like just a set of these eCash tokens with different amounts.
That's cool. So one thing that leads me to the question I have is then these different denominations, when you are withdrawing your coins, they can sort of, by the composition of the denominations, you can provide some indication of which deposit created that coin. Like, for example, if there's a weird denomination that isn't used that much in a deposit, and you withdraw that, you must be one of those deposits that was linked to that withdrawal. Is that right?
Yes, exactly. And like typically the only reason why you would have a weird denomination is because it's too big and nobody else uses it. Every other denomination should be relatively equally distributed, assuming that everyone has like roughly the same amount of money, or like at least that there are enough people with the same amount of money as you. But if you're a really rich dude in a poor community, then that might be a problem because nobody has 1 Bitcoin tokens and you're the only one that holds 1 Bitcoin tokens. So you don't have any anonymity set. And what we would do there is we haven't implemented that yet, but it's on the roadmap. We need the API endpoint that tells you how many tokens of each denominations have been issued. And then you could decide, like, do I actually want to issue like the first 1 Bitcoin eCash token? Or would I rather issue like 10 0.1 Bitcoin eCash tokens where I have some anonymity set? And then you can also analyze, like, if you suddenly have like 100 times more 0.1 Bitcoin eCash tokens than 0.01 Bitcoin eCash tokens, then you notice like there are a lot of people that are doing this. Like maybe I should be the first brave one that actually issues the 1 Bitcoin eCash token, and then others might follow because they see now like someone is using that. Yeah, that's a really interesting thing to research. But I think generally, if you can assume that everyone has the same distribution of eCash tokens, then these denominations don't really leak anything. Like I don't have a proof of it yet,
I guess,
but like intuitively it makes sense.
If you have like okay, so in practice, what do you think, what denominations would you recommend? Like this question is interesting to me. Would you do it like by bit, or would you do it like by decimal or something like that? Or would you use like a more clever scheme to sort of partition the amount space, and then, you know, use some algorithm to generate the sort of most fitting in set of denominations for any particular deposit amount?
Yeah.
Is that something that...
So I think when you don't take into account change and just want to optimize the amount of eCash tokens that you need, then you will end up with something that you take a base to some exponent. And you could either do base 2, which is like the bitwise decomposition, or you could use base 10, which is like our decimal system decomposition. But everything in between would also work. So the trade-off there is the more denominations you have, the smaller your anonymity sets get. And the bigger your anonymity sets get, or like the fewer denominations you have, the more tokens you need on average to represent an arbitrary amount. So it's a trade-off, but I think for like what I'd be going for is just decimal decomposition, like just all powers of 10. That's pretty simple, easy to understand. You have relatively large anonymity sets compared to like binary decomposition, and it's still efficient enough.
All right, cool. So yeah, next area is I wanted to talk more about this BFT, because I guess this is something that's not so well understood by most engineers in Bitcoin, because we don't usually do BFT algorithms, because that's what everyone else is doing. We have the proof of work thing. So I was wondering, yeah, what exactly is decided upon with the BFT? And yeah, so this if we can go to like some structures or some data structures that are transmitted or agreed upon in the BFT.
Like the main thing that's being agreed upon are transactions, because like that's really what describes most of our state transitions. Because I think the best way to think about federation or like any consensus system is that it's a distributed state machine, and as long as everything happens deterministically, we don't need any consensus, but only when there are state transitions where people might have different views on it, like that depend on external information, then we need to achieve consensus on that.
Yeah.
And like transactions are the typical way how state transitions happen in our system, but we also have different ways. And let me look that up.
Okay, so yeah, maybe talk us through the life cycle of a transaction, a depositing transaction. What is the first thing that happens, and then when does it arrive in the BFT? Do we agree in it that it exists through the BFT, or do we agree it in some other way?
Yeah, when we're talking about the life cycle of a transaction, I should actually just get the document I created for one of our weekly meetings for Minimint, and I will switch screen sharing in a moment. Just need to find it here. Let's zoom. Like Zoom is really the most useless app. Like it just minimized itself into like some weird form. Like how do you, here it comes. New share. Lifetime of transaction share. So you're seeing my browser now?
Ah, great. The life of a transaction. Here we go.
Yeah, exactly. Yeah, because that's a really good starting point to understand Minimint. And we have already talked about the transaction by now. Like maybe one interesting thing that I left out so far is that a transaction also has a signature. That has a really simple reason, because inputs, like eCash tokens are bearer instruments, like bearer tokens. Whoever has them can spend them. And if I didn't require a signature on the transaction with a like secret key related to like the input, then everyone could just take the input and bind it to a different transaction. Like you would have rebinding attacks. Like for example, a malicious federation member could take an eCash input out of the transaction, put it into their own transaction that pays them instead of my friend, and then front run me. But by having public keys associated to inputs, like each input has an associated public key, we can require that there's a signature by all these keys associated to inputs over the whole transaction, especially over the outputs, because that's what we're interested in. So that's why there's a signature here.
Oh, okay. Wait, so you're validating that there was an intention to do a deposit? Is that what you're saying?
The
signature is from the person depositing, right?
Yes, and they're proving that it was them that did the deposit, because like the deposit proof on its own wouldn't tell that to the federation. Like anyone could have deposited that. And so how do you know? Yeah. Okay.
So the depositor was, and so the signing over the outputs to what are they authenticating though? I didn't
like the outputs are, for example, my eCash tokens that I want to have issued to myself.
Yeah.
And if there was a malicious federation member, they could easily take the input, which is like my proof that I deposited, and put it into their own transaction where they issue eCash tokens to themselves instead of me. Yeah. But by including like a public key in the input, I can just like ensure that the outputs are actually going to the right person, because nobody else than me could sign these outputs.
Yes, so he's the owner of the output. No, the owner of the output. The output would be the federation owning it, right? So who is the key? Which key is the signature under, and what is in the message? I think that is actually what I need.
Yes. Like each input has an associated public key.
Yeah,
that's probably the most important thing to know. And the message is the whole transaction, like excluding the signature, of course. So what you authenticate is that the person spanning the input actually wanted to pay these outputs.
All the inputs? Like each like aggregated?
Yeah, yes. Yeah, that's actually like the signature is a music aggregated signature.
Okay.
Like we use music in a hacky way here, not for signature aggregation, but for we use it for signature aggregation instead of like public key aggregation. But it's the same because we're signing the same message.
Yep.
Like it's not like with Bitcoin where I have what is it called? The different methods to hash. Signature? No, like the different ways of hashing a transaction. Like each input essentially has a different transaction hash.
Yeah. No, I understand.
So
you're doing
we don't do this here.
One. Yeah, but the key is that all the inputs together, all the keys in the inputs.
Yeah.
So all the input owners are certifying that this is indeed they intend to deposit to Minimint, and they're also signing something else, right? Must not just the transaction.
Yeah, just the transaction, like inputs and outputs.
But then how does the federation not do the attack you mentioned? Like how does that confound the attack?
Because the malicious federation member cannot produce a valid signature for different outputs.
No, but it can produce it for the same outputs.
And yeah, but you don't care, then you still get paid.
Because it credits it to the keys in the inputs?
Wait.
Who does it credit? Who gets the coins? Like, because if I'm trying to get coins and I say, here's this transaction, and it's here the input owners, and we only sign the transaction, how do you know who to credit the coins to? How do you know? How do you definitely know that the person who
the outputs are yours? When you look at the structure of an output, then you just put your blind nonces in there, and only you can use these blind nonces. Really,
I see. Sorry, the outputs are not Bitcoin outputs. They are.
No, that's like an internal Minimint transaction. Yeah.
Now I got you. Sorry.
Yeah. Like you have different input and output types. Like that was that's what I was trying to show, like in the editor previously. Here, unfortunately, I only have the input. But I think we could go to the code here. Yeah. And like on the output side, you have like different kinds of output types as well. Like mint outputs, that would be like blind nonce that the federation will sign. Could be a wallet output, which is an address and an amount that you instruct the federation to send Bitcoin to on-chain. or Lightning, which is a little bit more complicated, and we might get to it later.
Yeah.
Okay, so now that we got that out of the way, we really understand transactions now, which is great. And like, how do these transactions get constructed? Like we already did the example here with the deposit. That's great. We have a client library which has different modules, like for the different federation modules, that are each able to produce inputs and outputs for their respective module. And then, for example, if we do a deposit, which we also call pagan because that's the liquid terminology, and that people told me it doesn't sound good, so we try to change it to deposit it eventually. Like there we create, first we create the input for our internal transaction using like the TX out proof for our deposit transaction. Like maybe I should explain this a little bit better in a moment. How do we even get to the deposit transaction? But then on the other side, we create some change. Essentially a deposit, we just create the input and then tell our client that please fill like the output side with change. Like we want to have it all as eCash tokens. So we just use this function that is normally used to create change if we have like both inputs and outputs and just want to have the differences change. That's what this function was initially intended for, but essentially it creates enough eCash tokens on the output side that like all the input Bitcoin are consumed.
Okay.
Yeah, and then we have a transaction that we just submit. So, but talking about the deposit.
Yeah, so a Bitcoin transaction is coming in and we can prove that we owned it. And I guess that was what I was getting confused by.
Yeah.
And
exactly.
that turns us into a Minimint input that we can then use in the Minimint land. Okay, I got you.
Yeah, like how you do the deposit is you take the federation descriptor and you tweak it. Like the federation descriptor is just a bunch of static public keys, and you can tweak all these keys and create like your custom descriptor that only you know about. Then you deposit Bitcoin there, wait for it to get confirmed, and then you can create a TX out proof, which is like a Merkle proof that your transaction was included in a block, and give both this proof, the transaction, and the tweak. So the federation actually knows that the address is owned by them to the federation, and that is like a transaction input, like a wallet transaction input for the federation.
And once again, we go as the client, we go to all the federation members to do that, right? All the ones.
Yes, when you submit this transaction struct, then you just submit it to every federation member.
Yeah. Okay.
You could also do it like first you submit it to one of them, and then if it doesn't get confirmed, then you submit it to others. That's also possible, but might be a little bit slower in some circumstances. So as long as we are not really worried about being overloaded on the API level, then we just submit it to everyone. Maybe we'll optimize in the future.
Okay, so let's carry on. What is now?
Yeah.
How do we get this transaction? Let's carry on. What is this life cycle of it?
Yeah,
so
exactly.
The client submits it.
We first submit the transaction, like then it comes to the federation. Like that's code inside the federation. It does a bunch of checking, like it validates that all the inputs are valid. Like we just iterate through all the inputs, and then depending on which module the input belongs to, we delegate it to the module to check. So we do the same for all the outputs, and in the end we just insert it into like our proposed transaction database row. Like we have a key value store, and there's a certain kind of key for proposed transactions that we will try to submit to the consensus next.
Yep.
Yeah, and that's what we're looking at next. When we are constructing a consensus proposal, yeah, I think we can ignore the drop peers here. What we're actually interested in.
I'll ask about the drop peers at the end.
Yeah. The items, like first of all, we query all the transactions, like all the proposed transactions.
Yeah, how did we decide even that we're going to send a consensus protocol? Like in the architecture, what triggers that decision? would a deposit be enough, sufficient to do that, or do
Yes,
you do it every
yes.
5 minutes? Or okay,
That's actually a great question, because until like a month ago, roughly, we were just doing as many consensus rounds as possible, like just in a loop, and it was quite wasteful, both on like CPU time and storage space and everything. So now what we actually do, but I have to find it, yeah, is we have a function called await consensus proposal that awaits any of the following. Actually, I think it's used somewhere else, but it awaits that any module wants to create like a consensus epoch, or like, I'm wondering, like, yeah, and then there's also the option that the transaction triggers that. Like either one of the modules or transaction triggers that, but I'd have to see where it's actually used. Yeah, it's in a different file. I'd like to have my editor right now, but like all the links go to GitHub. It's a bit annoying to switch between them.
That's all good. All good.
Yeah. So anyway, like we can trigger it with either transaction, or the modules can trigger, for example, because a new Bitcoin block was mined and we want to have consensus on that fact. Like that's, for example, like the wallet module would trigger a new
when you say triggered by
round.
transaction, do you mean trigger by on-chain transaction, or do you mean trigger by
always internal Fedimint transactions? Like on-chain transactions don't really concern us as the federation. Like we don't really care about that stuff. That's
so it's
actually
always
quite
the
funny.
Who's managing the on-chain thing and then posting updates to you. Okay, great.
Yes. Yeah, that's the great benefit of having the user send you like a TX out proof for the deposits, because then the only thing the federation really has to know is which block hashes it considers valid. And then you just check if the like root of the Merkle tree is like one of these block hashes, and you're good.
Gotcha. Yeah. Okay.
So but we were at the consensus proposal stage. Like we want to propose a new consensus round, and what we do is we collect all the transactions that users submitted till then. Might be only a single one. Like if it was triggered because of a transaction and there was no backlog, then it might be a single transaction. And then we also ask,
sort of scanning your database, just like looking through all the data. Like here's the things we could do in the next round. Here's what I have. Many times it will just be one thing, because that one thing existing is the thing that triggered the thing in the first place.
Like we do like find by prefix, which is just scanning for certain database prefix. And then we also query all the modules for what they wanted to propose for the consensus round. For example, the wallet module will always try to achieve consensus on the block height. What are the fee levels on Bitcoin? Then it also has some consensus on some entropy, like that we have the same entropy to refer to as a federation. The mint might want to exchange some partial signatures, like signature shares, or Lightning might want to share some decryption shares for a pre-image. And like all that is put together into a consensus proposal, which I hope that's in the same file. Okay. We did a bunch of refactoring here, and like Jay Kidman, like a really great new contributor to the project, did that. So sometimes I get a little bit lost, because I had it all in one big file and it was a big mess, and he plugged it apart. So yeah. Maybe I actually looked it up. Yeah, actually I have a link here. That's great. I'm prepared actually. Yeah, because we have the thing called run consensus, which just runs the whole consensus in a big loop. And what it is essentially, we get the proposal that we just looked at, like the function previously, and then call run consensus epoch, which is just like delegating to HPBFT, which is our consensus algorithm. You can see it right below here. Essentially, we just propose to the consensus that we want to agree on these items, and then process a bunch of messages in a big loop. But that's not all that interesting right now.
There's something interesting there, is that you pass in a future for the proposal, and then you wait for it inside. Wouldn't you wait for it
Right.
outside? Or is that just like just a minor implementation detail? Or is this like important there?
I think that's just a minor implementation detail at that point, or it might have something to do with, just a moment. Yeah, it was the other file. I can't really see why we would pass it in. It might be a remnant from, like we have another place where we await to do anything at all.
Mhm.
Like, because we don't want to run these consensus proposals in an infinite loop.
Mm-hmm.
Yeah, and I think that's also not the most up-to-date version of the code. Like I did this like 3 weeks ago. So
Oh, good.
like maybe here it was still like, okay, we actually have to wait for the consensus proposal. Yeah, anyway.
Yeah, all good. Just a minor thing then, probably gonna
Yeah,
change.
yeah.
I always like to ask that when I see something odd. I was like, okay, what's the thinking here?
Yes,
So,
definitely.
but in this case, nothing much to it. All right, no worries.
Yeah, that's the general approach is we create a future that lets us wait for if anything happened. Like it might be that this is the future here right now. Also, I think in the newer version that has changed. But yeah, we want to wait for anything to happen, like a transaction or a block being mined. Otherwise, we don't run the consensus.
Yeah,
and
makes sense. Cool. So
yeah.
I think is there any more in the life cycle of the transaction?
Definitely.
Okay, let's go.
Like the more interesting thing is actually when we achieve consensus, because then we have a bunch of transactions that we actually want to process, and like we have agreed on them that they will happen, and so we can now process them deterministically, independently, every federation member. And essentially what we do here is first of all we check that like the inputs and outputs of the transaction like add up to the same value on both sides, and then we just try to apply each input to like the database essentially, and it also validates like if the input is valid, if the signatures are valid, everything, and if anything of that fails, then like we also use database transactions, or like the concept of database transactions at least.
Well, when we're doing a signature, we're not talking about an on-chain signature here. Once again, we're talking about a signature that is
nothing
authorized.
on-chain.
Yeah, so it's talking about some authorization of the token holder. Is that more like what it is?
Yes.
Okay.
Yes.
It happens to be
like
a
you
Schnorr
mean
signature
that
in
validate
practice.
signature here.
Yeah, it happens to be a Schnorr signature in practice, but or not. I wouldn't expect it to.
Yes, it is.
Oh, it is.
Because we want to use music. Like I showed you before.
Okay, so yep. Okay, you use the music there. Okay, so that.
Yeah, generally for everything new we just use music, because only when we have to integrate with legacy Bitcoin stuff, then we use normal ECDSA. But why would we still be using ECDSA? I couldn't really see a reason to.
No, I would have thought like something to do with the token being a BLS thing or something, but I guess that doesn't make sense, right? You use Schnorr signatures because that's the only thing you need to do with the BLS is to the federated mint to validate it. The user never needs to issue a BLS signature, right?
Yeah, and that's also a different part of the software. Like here we are validating that like all the inputs are authorizing this kind of transaction. The BLS stuff would be validated inside apply input, for example.
Okay.
Yeah.
And so outputs don't involve, but an output could be give me another token, right? Give me another mint. Yeah, the output could be a mint.
Yes.
Okay.
That would be like a mint output. We would give the federation a blinded nonce, and the federation would then try to create a blind signature for that. It means like each federation member creates a blind signature share. They exchange it through the consensus protocol, and then in the next epoch they combine them, and then they are made available to the user to query. And that's something the user would subscribe to, for example, through the WebSockets. Like that's why I mentioned, like sometimes operations take a long time because the federation first has to agree on a bunch of stuff, and then it would be given to the user.
So with BLS, the user is simply verifies BLS signatures, and
Yes.
issues generates nonces in the form the BLS blind signing requires.
Yeah, and they
That
also
doesn't
unblind. They also
And
unblind signatures. Yeah.
Okay, yeah.
Yeah, but that's
Yeah,
all localized in the Mint module. Like, there's no dependency on anything BLS in the main Minimint repo. Not repo, but the main crate. Yeah.
Yep.
So we separated the concerns quite well here, I think.
It looks very nice. Yeah, I like the input-output idea. Right?
Yeah.
That's really
And eventually, like, my big dream is to actually not have this match statement here, because it's really annoying. Like, that way you always, like, if you want to add a module, then you have to edit that. But ideally, we could build like some sort of generic struct or like some hack to have arbitrary many modules mounted to the federation, and then just have like one of these that like matches the enum variant to the right module. And I don't know how to do it yet. Like we are missing variadic generics in Rust. Like with variadic templates in C++, it would be super easy to do. Like you just have an arbitrary number of generic type arguments to the federation, which are like modules, and they would define like what the transaction looks like, how this processing takes place. But in Rust, we don't have that yet.
Yeah. It seems like this can be done via a trait, like the self.mint and self.wallet, self.ln, they all have like one single function, apply output. So
what you mean probably is like doing a trait object, right?
Yeah.
And that's unfortunately not really possible right now. And we would lose a lot of type safety if we made it object safe. Because like currently we have a whole bunch of like just associated types to the trait, which doesn't work with trait objects at all.
Yeah.
And yeah.
Yeah, that makes sense. That will not work with trait objects.
Yeah. So one idea was to just like not have these associated types, and maybe have like an object safe trait that then like has the decoding logic, and only after decoding like you get these actual types, and before that it's just all bytes or strings or whatever. But the problem there is you would get decoding errors much too late. Like we want to catch decoding errors as quickly as possible, because that like a decoding error is essentially like someone is not honest. Like a federation member, if they submit a consensus proposal that cannot be decoded, then we want to ban them from the next consensus round. And we couldn't do that if it happens too late or too deep in the logic. Then we would also have to like keep track of who submitted which proposal really deep in the code, and it doesn't make much sense. So I'm looking into two options to achieve like this extensibility. One is to have a macro that generates, for example, the transaction code or like this match statement. Like that could all be a big macro that you just supply with all the modules you want to mount to the federation, and then all the code gets generated. But it's really annoying because macros don't have good tooling support. So a different option I was exploring is I have it in a secret just somewhere. Lego Fat, which is like a funny name for a concept. Like essentially, do you know heterogeneous lists? Like you can have on the type level, you can have a struct called cons, which has a type which is like the current type and like the next type. And it's like a linked list. The next type is like either nil, not a list, or like another cons. And that way you can like build types of arbitrary many types in them. You know?
So it's like it's an associated type, like each one would be an associated type of the next one or something. So you don't need...
Yeah, there is something called HList. Like it's
I know this module, yeah.
It's a lot of fun. I think it's actually not an associated type really. It's just like two types and the trait.
I see. Okay.
As far as I'm aware, it's the cons in the nil type. And then there's like different traits for different things that you can implement on top of this list.
Yes. Yeah.
And we could use that to like mount modules to the federation, but people haven't been that excited about it yet.
The H list, though, if you were to print out the H list, it would still, like, for example, that H5, it would still have like U32 string F32 bool, right, in the type signature. Thing. Yeah. So you would, what you're essentially saying is you're changing, you would add a type parameter which is more like represents the list of modules.
Yes, exactly.
Yeah.
Yes. That's exactly the thought here. Like M would be a H list, like the module list. And we only need a sec because unfortunately we don't have variadic generics yet. Like if I could just say I want to have like an arbitrary amount of type parameters that are all of type module, then that would be so much easier. But yeah, we don't have that yet.
I mean,
so if anyone is into like Rust language level stuff, then please push this forward.
I'm interested in avoiding it. So if you if you would just have like your enum there, right, and just make your enum implement a trait, and then sort of, I don't know. I guess it's because you have particular details that are associated. You have these associated types of each of the things, which makes it a bit trickier. You wouldn't get your type safety that you're looking for. So I think it involves either doing something insane or doing rearrangement of the relationship and dependencies. We'll not speculate on how that's done. But it's an interesting point of that you would like improvement on, which is always good to know if you're looking at a code base.
I think there is a trade-off here. Like we could, of course, make the federation module trait object safe, but that would eliminate a lot of the type safety.
Yeah, I get you.
So,
like if I understand it right, like because of that match statement right now that is going on inside the code. So now if somebody wants to add a new module and put that inside, they have to like go and change here.
Exactly, that's the problem. Like you cannot easily just have a separate repository with module implementation and then just like mount it to the federation, but you have to have it like in the main repository, which is really annoying. That would mean that people that want to build different federations with different module sets have to fork the repository. And we don't really want that.
Yeah.
Maybe add an enum variant called ox or whatever, and then have a type parameter for it, and anyone can define their own.
But that's like, I had this idea too, like just make enum with, for example, like 5 variants, and then have a module type, which is like the non-module that is just not populated and cannot have inputs and outputs. But that's really annoying. Like it's not a good solution in my opinion. Like we could do it, but I will try to avoid it.
Fair enough. So transactional lifecycle. I think we're not quite at the end, but we're getting there.
Yeah, exactly. Like we did quite a detour here, but we had just applied all the inputs and all the outputs to the database.
Yeah.
And assuming like that everything was valid, then at the end of the epoch, the database just gets applied. Like we call commit, and that like says like, even so we are leaving this function, we want to keep all the state. We have built our little own batch system here that we want to really get rid of. Like it's kind of clever in a way that if the batch is dropped without calling commit, then like all the changes are reverted. So we can leave the function via the question mark operator or the try operator and not care about like rolling back all the changes to the database. But it also has it's not a real database transaction, which would be much nicer. And it originated from some premature optimization that I did early on. Like I wanted to parallelize the transaction processing, and like database transactions don't work well if you want to do stuff in parallel in them. Or at least the database transactions of our database didn't like that. So
And
I built
not
my
super
own.
necessary for performance. Doesn't feel like it. I wouldn't have guessed.
Yeah.
I mean, the Bitcoin
So,
blockchain
and
can only make so many things. I mean, I suppose there's Lightning, but still, that's not like, shouldn't be that much.
yeah, the main problem here is that we're dealing with eCash tokens, and validating a single eCash token takes like 4 milliseconds. BLS is really, really slow.
Yep.
So that's why I parallelized it. But by now we have a much better like approach to this actually, and we can see this here. We have something called the verification cache, and like building the verification cache is a pure function. You get like each module before the consensus round really starts gets before the processing of the transaction starts gets an iterator over all its own inputs, and then like since it's the building of the verification cache is a pure function, we can like parallelize it. For example, we would take all the signatures from all the eCache inputs and verify them in parallel, and then just build a big map of that maps like this signature to is it valid. And then we turn this map as the verification cache. And later on, when we actually want to validate an input, we hand in like a reference to the verification cache, and the actual validation happens serialized. Like that doesn't happen in parallel anymore, but like all the heavy lifting has been done before in parallel by building the verification cache, and now we can just look it up in a table.
Yeah,
that might be interesting, like as a design pattern or whatever. I don't know. Like it took me some time to come up with it at least, and it's much better than parallelizing it all, because then you get into really hot water with mutability and yeah.
But yeah, splitting your code up into the pure functions and separating, applying those functions to your data, and then and separating that especially from all the operations that you do that require any IO is a very good approach, especially in Rust.
Yeah. Yeah, and yeah, I think that is pretty much the end. Like now that all the outputs and inputs have been applied, like the only thing that still has to happen is that per module, we might have consensus items, like the partial signatures that still need to get exchanged, and they will be processed in the next round. And for example, what do we have here? That's in the Mint module. Like at the beginning of each consensus epoch, if we had any like consensus items, like these signature shares, then we will try to like process them, and process partial signature. We'll write them to the database and then check if we can already combine the signature shares that we have.
Signature shares, we're talking about shares of a BLS signature?
Yeah, special shares of the special blind signature scheme. Yep. In that case. Yeah, and you need at least T out of N of them to build the blind signature to give back to the user. Yeah, and so you would do this here. Yeah, and that's pretty much it. That's the life of a transaction.
That was fantastic, and thank you for this document. That's really helpful. So you have a wiki as well. That's great. So yeah, there's a wiki you can go to look up some useful hopefully not outdated documents.
Yeah, we are trying to like migrate this to the website. Like currently there's a website pediment.org, and that's a bit outdated. In fact, like we have the architecture has stayed pretty much the same, but yeah, like we could explain it much better. And someone in the we also have a Discord, by the way. Don't want to go in the private messages. Yeah, but we have, for example, like the design Discord channel here where PW, I think Peter is his name, is working on. Oh, he's here. Nice. Hey. Is working on a really cool new wiki. That's okay. Apparently that link is broken. We'll try another one. Yeah. Like that will contain like a lot of other resources, like better graphics, and like I hope it will soon be on pediment.org. Like, thanks for your work there. Since you're here, like I didn't even notice. Yeah.
Nice work.
And like, yeah, you have like some beautiful graphics here, and I don't know which pages are best to look at. Yeah, that look pretty good. It's just way better than what I could ever do. So really looking forward to having that on Pediment.org.
Diagrams looks amazing. What kind of tool you are using to make them?
Very good question.
To make this website.
No, this
Make the
diagram
pictures.
like this.
The pictures. It's in Excalidraw. So I don't know if you've used that before, but it I have it. I do a lot of my note taking in something called Obsidian, and there's a plugin that will link these Excalidraw pictures into Obsidian, so you can do like an infinite whiteboard type thing. But the output of all the drawing files is a vector file represented in JSON. So you can also then check all of those diagrams into Git as well, so anybody else can pull them down and then adjust them, which is a nice side benefit.
Looks
But yeah,
like
it's
hand drawn. So you're like using some kind of like pencil tab or something like that.
Yeah, no, it's I kind of said yeah, nah. It's very Australian response. It's this Excalidraw. It does fake hand drawn diagrams basically, so that you draw it on your computer. You can hand draw over the top as well. So there's a few bits where I do that, but most of this is
really
actually
cool.
just
Thanks
yeah.
for the reference. Excalidraw,
no worries.
you say, right?
Yeah. So if you went to like, I think it's excalidraw.io, you just get presented with a whiteboard and you can start straight away, send the link to somebody else and they can jump on the same whiteboard. I think it's .io.
Yeah, it's .com, I think.
There you go. Yeah.
Yeah.
So that's the one. Okay, Excalidraw. That's exactly the kind of weird information I'm hoping to pick up from these sessions, other than the main content. Thanks, Pete.
Yeah,
no,
but good to know. Like, if that was your real handwriting, I'd be very jealous.
It's not.
So we've been through the life cycle of a transaction. I think I got it all. One thing I'm still like not 100% sure on is, what do we do once the thing has got consensus, the transaction? Do we sign anything before it's got consensus and then pass our partial sigs around, or do we wait till everyone agrees and then pass our partial sigs? I think I didn't get that.
We wait till everyone agrees. Like, we could do it as an optimization to already generate our partial signatures. But the problem is, without having consensus, we don't know if like the transaction will be in the next round. And so we can't even punish anyone who does not submit their signature shares. Like, once we have consensus on a transaction, we expect everyone to contribute the signature shares, and we can punish them if they don't.
Punish them by dropping them. That's that dropping.
Yeah,
thing
exactly.
To go back to.
Yeah.
And explain the dropping thing. And what do when we can achieve consensus, like you're achieving consensus about someone not sending you information. Is that correct?
Yeah, that's the great thing about consensus algorithms. They guarantee that, let's say we have a bunch of members that all make contributions to the consensus. Not all the contributions will get into the consensus, so not everything will be output by the consensus algorithm. But the guarantee that it gives us is that every honest participant will get the same output.
Yeah.
Like, we cannot make any guarantees of this, what the output is, or what will be in the output, but we can say that everyone will have the same.
Yeah.
So that's like the beauty of it and why we need it in the first place. So if we know that everyone has seen that the transaction happened, and then one of the peers did not contribute a signature share in the next round, then we can be sure that they are malicious, because everyone got the same information that they didn't contribute, because everyone saw the same output.
Yeah, because
that's actually
the BFT algorithm is like a black box, which is just ensuring this.
Yeah.
And you are in the part of the BFT, I guess you're sending messages to multiple of your peers.
Yeah.
It's all of them?
Yeah, you have a bunch of rounds between all of the members. Like some messages are sent to everyone, some are sent to only single participants. There is a really good
and it's
paper.
sort of randomly chosen, right? Sort of like it uses randomness in the algorithm.
Yeah.
So this is the Honey Badger BFT, which is by Andrew Miller and al.
Yeah, it's a really great paper, I think. I read it some years ago, so I'm not all that like it's not that much in my head anymore, but it's really good, easy to read, I think. And I guess it's a cool algorithm. There are better ones now. I think it's from 2016. And for example, there's Dumbo now, which is like 1 or 2 steps ahead of like Honey Badger, just built on improvements that were made to Honey Badger.
But with Honey Badger, you have a Rust implementation.
Yeah, exactly. That's like the big benefit. Yeah, like Shitcorners did something useful for once. They built us a HBBFT implementation. Yeah, I don't know what kind of shitcoin network it is, like poor network. I think it's some sort of
proof of
like
activity.
Ethereum. I don't know. Some private Ethereum stuff.
Gnosis was like a Oracle thing at some point.
Oh,
I don't know if they keep changing.
I don't know.
No, it doesn't.
Yeah, I never really understood it. They seem to do some stuff with EVM.
Okay.
But I don't care. They gave us like a beautiful HBBFT implementation. The code is actually really good. I liked like the architecture and everything, and I don't fully understand it. I'd say.
Well, tell us what you like about it. Like, what is the thing you really like about it?
I have to look it up, but they have like I'm not sure if it's a trait, but they have many protocols in there, and each protocol works the same way essentially. Like it produces messages and it consumes messages, and each consumed message leads to like a outcome in a sense, which either contains more messages to send to peers or to or with some output that you can process. And like you can really easily nest these different algorithms, and that's what they do. Like they have a subset algorithm, they have like broadcast, binary agreement, all kind of stuff, and it's all nested in Honey Badger in the end. And then they have like a dynamic Honey Badger where you can even replace members of the federation, which is also just a Honey Badger nested in another layer. Yeah, I don't think we have to go into this too deeply. Like I haven't looked into it in a while.
The thing that you liked about it is it's like got all these protocols, and you have this pure functional API that you just tell it, I want to do something.
In a sense, yeah.
And then it returns you things you have to do, and it doesn't care how you do them. And then you go back and you get send some network messages. You get and it tells you which peers to send them to, right?
Yeah,
and
exactly.
And then you can go back, map those peers to your application domain, send the thing, do the thing, get the things back, and then put them back in. And then it'll then give you new things. So that's a really nice design.
Yeah, and each of the sub algorithms acts exactly the same way, and it's kind of beautiful because you can nest them. Nice. And then just need to build like another enum for the message, and because like some message of Honey Badger might be like a binary agreement message, another one might be like a subset message from a different sub protocol, but in the end it's all just a Honey Badger message.
Cool.
Yeah. Anyway,
there was
digressing a bit here.
No, that was a really useful digression for me. One thing I wanted to understand is about your database, your storage layer. So what the key question for me is how bad is it if you lose data? Like if your data becomes corrupt, is there some way of recovering from that? If your database is offline, I guess you just don't send any messages. But if something is wrong and you accidentally load a database from an earlier consensus round or whatever, what is the stakes there? Do you just get banned because you're a bad peer now, or is there some way of recovering from that situation?
Like if a single peer loses their database, then we don't really care that much because like first of all, they can recover their entire state from their peers. There's no private data in the database, to my knowledge. It's just like the state of the state machine.
Yeah.
So we still need to build a way to like authenticate this data. Like ideally, we would have a signed commitment to the current state of the system, so that you can easily replicate just the entire database and then check that it's what everyone agrees on right now. But if you cannot do that, you could just get the databases from all the other peers that you assume to be honest, or like not assume to be honest, but if they all agree, then yeah, then they're probably at least all honest or at least all dishonest. And if they're all dishonest, then you're out of luck anyway. So that way you could recover. If everyone had a corrupted database in the same way, then that would be really bad, because, for example, people could double spend.
Yeah, that does sound bad. You'd have to shut down the mint at this point or something. I don't know.
Yeah.
But okay, so the mint, you can theoretically recover. Doesn't matter if it's implemented or not. But it's not so crucial then. What you save and what you don't save. Like, let's say you mess up, you can always recover, and you cannot be tricked into losing money as long as you've got, you know, some other honest parties, or you have to take some social recovery there, I guess.
Yeah,
is one way to look at it. Okay.
Like, we really don't want to mess up our database because the recovery process is terribly annoying and not really implemented yet. But in theory, it's not as big of a problem because we have this replicated state, and we could recover from it.
It's mostly public data.
Yes.
You just don't know what the inputs you could, or the on-chain deposits you can see, but you cannot see the Lightning deposits anymore, I guess, and you cannot see the Lightning withdrawals anymore, or you cannot guarantee that they existed. Is that sort of, or if you keep your Lightning channel?
Actually, we are not dealing with Lightning channels or Lightning at all in the Federation. That's like the cool thing. Maybe you should go into that. Just to like wrap up the database thing. Like, we only recently switched from SLAT to RocksDB. Okay. Because like, that might be interesting to you. Like, SLAT is like a pure Rust implementation of key value store, but it's not really maintained anymore. So it was a bit scary to use it, and it was also said to have some bugs. So that's why we migrated to RocksDB, which has much more traction. And also the Rust bindings to RocksDB just got transaction support, which is great.
Okay, cool.
Yeah. So, but we are talking about Lightning, and that's probably interesting to look at. Let's see. For that, we will take a look at the Lightning module, because the Federation itself doesn't have any channels.
Before we go there, I'm just trying to get it in my head. The thing I have a database store for, my state is really important, just so that I don't issue new BLS blind signatures, right? That I already issued.
I mean, that's for the mint part, yes, but there are many other parts. Like, we also don't want to allow redeeming on-chain deposits twice. Like, we have to save that the user already redeemed the on-chain deposit.
The on-chain, yeah, but that's a BLS signature. But when they redeem it, they get they get a BLS blind signature, no?
When they redeem it, they get a blind signature, yes. But the deposit itself, like, it's just to prove that you sent money to the Federation, and you need to remember that you actually got, you already know about that money. Like, if you forgot about that user redeemed eCash for an on-chain deposit, then they could redeem money for the same on-chain deposit twice.
I was assuming that, like, they could figure that out just by looking at the chain.
No, they can't. Unless they already spend it, they can't. Because you're not spending money just because it was deposited. You just keep it in like this
there is a redemption, right? Where they're withdrawing from the mint. You issue a transaction, Bitcoin transaction, to withdraw it on chain. You give the broadcast the transaction, but then maybe it isn't confirmed yet or something. And then, is that the problem? And then they make another one.
No, not really. That's a different problem. That's also
it's about linking the withdrawal transaction. I mean, you cannot. You just.
It has nothing to do with withdrawal, actually. Like, just the deposit. Like, let me go back to the structure of a transaction. Like, the input for deposit is the wallet input, and the wallet input is like just the proof that you send money to the federation, right?
Mhm.
Like it's a Merkle tree that the transaction was included in a block.
Yeah.
And like we have to save that someone already redeemed this deposited money.
Used it as an input in a transaction.
Yeah,
Are we-
exactly.
Yeah,
like
okay, right.
yeah, that you cannot use the same proof over and over again,
Mhm.
because on chain the transaction is still there, like the deposit is still there,
Mhm.
because the federation hasn't moved it yet,
Mhm.
because there might not have been a need to move it.
Mhm.
So there's no way to recover the funds from on-chain. Like that's different than, for example, with hierarchical deterministic wallets,
Yeah.
where you can always recover from on-chain. Like for our use case, you actually have to remember the tweaks to your descriptor, otherwise you lose your funds.
Yeah. Okay. Yeah.
Yeah, but fortunately they're highly redundant, because everyone saves the tweaks, and tweaks aren't really private. Tweaks are pretty much public data. And because they only allow you to spend a Bitcoin together with the private keys that are owned by the federation members. So you don't care who knows the tweaks. Yeah.
Yes, that's really interesting.
That
I
sense,
really
like,
like your design, by the way.
Will it be useful to have this kind of setup, like where people are like sending in the funds to the federation address, and the federation is like periodically like sweeping the funds out, so that they don't run into this kind of situations where they forget a transaction came to that address?
That's definitely something we are thinking about, to build like a HD wallet too. And like the main problem is the federation cannot make a transaction on its own. Like it always needs a user, because someone has to pay the fees. Because if the federation was doing a transaction on its own, then it would lose some sets for fees, and then it would be fractional reserve. Like we have a really zero tolerance for like making any profit or losing money. Like each transaction is perfectly balanced. Like unless you define you want to make a profit, you don't make a profit, and you also then can't lose money, because then you would go fractional reserve.
That's a hard edge to balance.
Yeah. So the only way that we can make an on-chain transaction is if the user requests us to do so. And at the same time, we could just take the money inside a HD wallet at that point. Like the change could go to a HD wallet.
Yeah.
And that might be the way to go eventually. Or even like just using an HD wallet from the beginning. And like the only annoying thing about it is to generate an address, you need a consensus round, because you need to decide which index to use for the specific deposit. Yeah, but that's okay, maybe for some use cases. And then we don't have this complicated tweaking deposit mechanism.
Cool. Okay, I didn't. So yeah. So but there would doesn't the that's interesting. Doesn't the federation have a change address, or a change keychain or something, or BIP32?
Currently, the change would go to like another tweak descriptor. Like there's a change tweak agreed upon each round, each consensus round.
Yeah.
Yeah, so we avoid like having two systems in parallel, because that would just be a lot more complexity, and I didn't want that in the beginning. Keep it simple.
And so you know
actually
for that, and so you issue the tokens to yourself, nominally.
Yeah.
Okay,
Yeah.
cool. That's really nice design. Nice. I like it, man. Okay, I wasn't expecting that though. I was expecting to have a change thing, but that's a clever solution.
Yeah.
Okay, so I think that actually does it for the structure of the code and each of the components. That was really good. I got some follow-up questions just about sort of like your attitude to Rust programming and the particulars of sort of the tool chain of you're using here. So one question is that's really important is, how do you test this Minimint?
Yeah, so we have both integration unit tests, and way more integration tests than unit tests, I have to say, because the problem is with unit tests, they get outdated really quickly.
Yep.
And so we have a few scenarios. We looked it up. Minimint in our integration tests. We actually both have integration tests in Rust and in shell script. The Rust ones are able to mock out certain parts. Like, for example, network communication can be mocked out in Rust, while the shell integration tests are like fully the real deal, like what you would deploy in practice. But ideally, you can catch a lot of problems in the Rust integration tests already, because there you can step through in the debugger, because like it's all running in process. Like you have only one process, and that's really convenient. Yeah, and then we have like certain scenarios like the packers rejected fees are too low, or like all kinds of things that we want to avoid or want to ensure.
And so with this testing is like, do you run a Bitcoin RPC node? Do you test it against a reg test node, or is that not? You don't feel like that's in scope?
Like it depends. Like the REST integration tests are both able to run against the real Bitcoin node or against the mocked out version of it.
Oh, you have a mocked out Bitcoin node?
Yeah. Like where is it? I always forget if it's in the API. No, it might be in core. Anyway, like we have a trait essentially.
What's the scope of that? Like that
just the functions that it's just the functions that we need. Like it's, I think, querying the block hashes and I'm just looking up in which module it is. Okay, yeah, it's actually really simple in Minimint wallet. Yeah, you had this question about when to use traits, and that's one of the reasons. Like most of the time we use a trait, we use it to test, like to be able to mock out the real thing. And for example, we have a mock implementation for Bitcoin RPC that will give you a different like block hash, different block height, like can manipulate it all. But in the final like integration tests that we do using the shell scripts, there we just where is it?
You're just using the RPC interface most of the time, I guess.
Yeah, exactly.
To see that the stuff happens against a Bitcoin RPC node as well, I guess.
Yeah. Like we set it up. We start like the Bitcoin node in reg test, then wait that it comes online. And,
yeah. I've written this code.
Start a bunch. Yeah. It's not great, but it's what you have to do to be entirely sure that it works, because like mocking only gets you so far.
Yeah, we went. I agree with that. We went with this crate called test containers. So we test against Docker eventually. Like the Docker you spin up inside a Rust test. So you like give me a new Bitcoin RPC, Bitcoin D. Node.
Can you do that in GitHub Actions actually? Because it's already running in Docker as far as I'm aware.
Yeah, you can. Yeah. So that's what we did. This is a project from a while ago. But yeah, we did that. It is much better. Like I was skeptical. I was like, no, the shell scripts are good. But then someone was like, no, this shit. And then they rewrote it. And the tests run inside their Rust tests. But they run a Bitcoin D node.
What is it called actually?
It's called test containers. You can just put it in the Docker. Yeah, that's it. I don't know how much it's used recently, but we built that at our startup there.
Nice.
Actually.
Cool.
We were learning Rust at the time, so I think some of the APIs are not exactly as you want, but I think it is better than running shell scripts, I would say, still, despite our clunky APIs. So yeah. It's a Java library thing that existed, I think, and then we made a Rust version of it.
Nice.
So yeah, you can give that.
Yeah, we might switch to it too.
There's
like
also
we just said,
there's also a Bitcoin D crate that actually we use in
I know, I remember.
that we
I think you can
use
do that on Rust also. Like I wrote some test in BDK CLI with Bitcoin D. Like you can
Yeah.
spawn a Bitcoin D in the background and connect with that with
Yeah.
this RPC and do your
Yeah,
tests.
great. This doesn't need Docker, so it's actually better.
Yeah.
And
I'm not even sure if
yeah,
we might be using it in the Rust integration tests, but maybe not. I think we just use the same setup script there too.
Mhm.
Yeah. But in the end, I think the Docker version would be much nicer, because we might even be able to use like the final deployment Docker images. Like we want to build some Docker images for deployments eventually. And if we could use these in integration tests, that would be awesome.
Oh yeah, right. Your Docker, the same image you use for your publishing Docker Compose or something like that. Okay. Cool. Yeah. So that does the testing. Do you finally, do you have any part of the code that you're like quite proud of? Now, I think the answer is like your transaction structure and how you've managed to like avoid this caring too much about each of the modules. You just have these inputs and outputs, and it's all kind of nicely arranged. But do you have anything else that you're like?
Yeah, I think generally like the module abstraction worked out pretty well in the end. Like it has become a little bit more complex recently, but yeah, it's still, I really like the abstraction because it forces you to think in the same patterns for each of the operations, or each the different representations of Satoshis. Because in the beginning, I just had like a transaction struct that had like a deposit variant, the eCash transaction variant, and withdraw variant. And like these were all custom implementations for like, okay, in both the deposit and the eCash transaction variant, we issue eCash tokens. So I had this code application there. And in both the eCash transfer and the withdraw, we have to validate eCash tokens. So code application again. And especially once I wanted to add Lightning, like you have the combinatorial complexity. Like what if you want to like fund a Lightning transaction with like on-chain deposit, which is kind of stupid, but could happen. And so it shows like this transaction model with different variants for these modules. And that makes it quite versatile. So now Minimint is more of a framework to build federations and not limited to eCash anymore. And I'd really like someone to build like a module that allows to have Signet sidechains. That would be really cool. Like, for example, Jeremy Rubin could just spin up a CTV as sidechain, and then we could just play around with it without, needing to merge it with Bitcoin first.
Cool. Okay, cool.
Like an open source sidechain implementation
that would interact with that problem we were talking about with the enum variants, right? You need to extend it somehow.
Yeah, exactly. That's why I want to fix this problem, so people can just build their own modules and plug and play, plug it together a federation.
So I'm interested actually in this federation module trait, because when I was looking at it, it seems to be one of those traits that is like there to just discipline you, right? When you're making one of those enum variants, right? But in practice, you're actually not using it as a type parameter, I think. Too much.
Exactly. Not yet. Like you have seen my H list approach.
I see. Okay. Yeah. Okay, so it's coming. The idea is that this is actually going to be a type parameter here and there, and a list of these H list of these federation modules, perhaps. All right, good to know. Yeah.
And we are also using it as a type parameter for testing.
Yeah, I saw that. Yeah.
Like there's a fake federation, I think. Fake fed. Yeah. And there I can spin up like a, as the name says, fake federation, which consists of only one module.
Yeah.
And there, like the module is like a type parameter, and all these associated types have to be constrained, and it's kind of a mess. But it's good to test single modules.
Okay. Because so the structure. So what you will have in the code right now is that you just call each enum variant thing module you have, because it's a fixed finite list of them. But in the future, it may be an extended list where this trait is really coming into play. But right now, you just have it for some testing, which is what you said the traits were for.
Yeah.
Anyway,
I mean, I really hope that I am able to build this agelist version.
yeah, it sounds
Let's
super
see. I
powerful.
think I had a more developed one already. Yeah, that also used generic associated types, and that made it a bit easier to build actually. And I think they will be stabilized soon. So yeah, then I could construct like mint outputs, process the output in the federation, where attach these modules. Yeah, that's pretty cool. Like that might be something. If you're really into Rust generics and weird text that you can do with it, take a look. But many people aren't really excited about having
I hate
this
I hate
hackery.
them. I always
Oh.
I delete traits whenever I join a code base.
Yeah, but traits are super useful. Like we mostly use them for testing, I think.
Yeah.
Like you gave me these talking points a long time ago, and you have a bunch of stuff here. Like, and you were asking about the traits.
Yeah.
Like
I'm
for us,
really
it's
interested in
mostly
this topic.
mocking.
Yeah.
If there are multiple possible implementations, like for example, the networking stuff, like we probably want to have both a Tor network stack and like a TLS TCP network stack, depending on if the federation members want to stay private from each other.
I see. Yep.
But you generally don't want to use Tor because it's slow. But if they really have a privacy need, then they could use the Tor implementation. Code deduplication for default implementations, that's something we use infrequently, but it exists. Yeah, and yeah, force myself to follow patterns.
Yeah, actually, like let's go to that since you prepared answers for those talking points. What have you learned about Rust over the course of the project? What's your takeaways? How long have you been programming Rust?
I've been in Rust since beginning of 2018, I think. So that wasn't like my first project or anything. So I didn't learn too much new things about Rust. Like mostly I got deeper into procedural macros, which was great. And then I found out how limited the type system is. Like that was an ongoing annoyance all the time. At first with const generics, fortunately we have them by now. And then with generalized generic associated types, we will be getting them soon. And periodic generics, okay, maybe never. I don't know.
Yeah. And this mistake? What are your mistakes that you frequently made at the beginning of the project that you've sort of realized the mistakes?
Yeah, I think the worst thing was using too many generics in places where I didn't need them, like where I had object safety, and I replaced them all with dynamic boxes essentially, because I introduced them to be able to test. But the problem is generics propagate all the way up. So in the end, like the federation would have had like a whole bunch of different type parameters, and that was really unwieldy.
Yeah.
And another thing we already talked about, like the over architecturing or premature optimization, like the parallelizing. Yeah, just not do it or build it back. Yeah,
gotta keep relearning that second one. we relearn that on every project, but yeah, it's the best.
Yeah, I know.
Okay, so have you specified the protocol?
That was a question. I was like, yeah, no, I haven't. That's the only honest answer. Like I wrote a paper about the concept, and there I have some proofs why this, like on the abstract level, why it makes sense, why it's secure. But like on the binary or code level, like there's no specification because it would just take way too much time. For the first year or so, I was the only person working on it, and it's much easier to gain traction when you have something to show to people. So building a prototype was much more important than specing a protocol, because nobody gets excited about the protocol spec, to be honest. Like maybe Rusty, but yeah.
That's right. I'm so totally with you. We need to do less specification and more more building things.
Yeah, and especially it's not Minimint or Fedimint isn't like Bitcoin. We can update it. Like if we want to write a specification and there's a weird quirk in the protocol that makes the specification really ugly, then we can fix it. Just fix it in the next version. And then we have a beautiful specification, beautiful protocol, and it works. Like that's the great thing about federations, you can actually update them.
Yeah, the thing I've realized is that it's great to have the problem that you have all these different implementations and users and clients, that you actually have the problem that you need a specification at that point. Like you need to get to the point where you actually have that problem. Don't try and make a specification before that. So I think that's what you're doing.
Yeah, I think, I mean, if you want multiple implementations, then you should probably go the way of having the specification first, but it's not really useful right now. Like there aren't enough developers in the first place working on that. So yeah, doesn't make any sense yet. With Lightning, it's a different story, I think, because there the idea was like we need multiple implementations to not centralize the protocol too much. So we need to spec a protocol.
Yep.
Yeah.
Yeah. So we got the one I need to ask is the mutability and concurrency, because it's just a difficult question that comes up over every single project. How do you make sure that the database is not being written to multiple places? Things like this, like the array or the whatever that holds the things that need to be put into the next consensus round. How do you make sure that these are all not being changed at the same time or safe, or how do you design it like that?
Yeah, like the best change we did for that was deparallelizing the consensus. Like the consensus is just like one thread, and that's the main thread that writes to the database, and everything else, like there's the API, which mostly reads from the database. So that's unproblematic. And if it reads outdated data, we don't really care. Like the client will just try to read again. Like with the notification system, it's getting a little bit more complicated. We need like notification types or notified. We use the notify thing from Tokyo, like this primitive. You can send notifications to certain parts of your code when something happens. But for the most part, like the only thing that does any writing to the database is the consensus. And then there's one exception, which is submitting transactions. And like there, the thought is, okay, we don't really care if the transaction that is written gets necessarily into the next epoch or next consensus round. It's not as important. Like there's like if there's any inconsistency, the federation won't fail. Like it might be annoying for the user if they have to wait for one more round, but yeah, that's okay.
Yeah.
So generally we avoid writing to database from different places, and where we do, we make sure it doesn't matter.
Yeah, nice.
Yeah. Like so we actually use the database as a way to communicate.
You do need to read from it though.
Yeah, yeah.
The RPC, I guess you need to read from it.
Yes. But we have like transactions on the consensus side. We have database transactions. So the writes are atomic, at least. And then when we read, we either read outdated data, which is okay, or we read the current data, which is even better.
I got you. So the way you handle that is you have a database handle that is read only for the RPC.
We don't really have that concept. That's kind of problematic. We cannot enforce that. But when I'm reviewing code, I would scream at everyone who tries to write from, of course, like the API thread.
You just informally. You have a database. It's like an Arc9.
Yeah, exactly.
Okay, so it's this kind of model.
And maybe we could even, maybe like the new RocksDB stuff has like both read only and read write handles. But I'm not sure yet, and maybe we will change our API accordingly. But so far, we haven't.
No, it doesn't need to be. I'm not demanding that.
Yeah, no, it's a good idea, but like it hasn't been that much of a problem yet, because like the main logic is in one thread. So, but just avoiding parallelism, that's like the best thing you can do. That's also what I learned, like with extracting the verification to make it faster. And that's a pure function, so you can parallelize it, and everything else like that needs to do anything with mutable data, just don't do it in parallel.
Sure. All right, Eric, I think this pretty much does it. I really found that very valuable for me. So I'm going to be taking a look at Minimint soon, and we're going to be hacking on it together, Raj and I, and a few others at an upcoming kind of hackathon we're doing in Kuala Lumpur. And it's this is going to be a great reference for that. So
awesome.
Thank you for coming. I do have one last question. It's in the
I've got another question as well.
Michael, go. Yeah, sorry. Everyone else, jump in here. Actually, go for it.
So it says on the README there's multiple known security issues. Are they with design or code or what? Like anything interesting there?
Oh, do you mean there are multiple known security issues?
Yeah.
Actually, right now I wouldn't say that anymore, but it's still good to keep people like away from running it on mainnet. Like for a while, we were, for example, forgetting about change in the wallet module because I just hadn't implemented it yet because it was a prototype to like just demonstrate the eCash stuff. And I never cared about withdrawing rectest Bitcoin. So I didn't implement it well. But by now I'm not aware of anything that's terribly insecure. Like we still need to go through all the fixmes that are left. But I would probably be comfortable with running it with like a few $100 worth of Bitcoin on mainnet by now. Yeah, and we're currently setting up like a SIGNet federation to play around with it. And then probably soon I will also set up a mainnet one that I can just dog food from day to day, like as my Lightning wallet.
Cool. Perhaps you can upgrade it to experimental then and take out the known security issues one.
Yeah, I should do that at some point. Just didn't bother yet because it's good to keep people away from doing too reckless things. So I'm happy about losing my money by playing around with it. I'm not so happy about losing other people's money. So, and you see what happened with Lightning. Like it's super reckless. You couldn't even run the precompiled versions on mainnet, and people just patched out to check if it's mainnet or testnet, and ran it anyway. And I bet a lot of people have lost some money in the first few months of Lightning.
Well, that was actually my question. So
seriously, I was reading your mind.
That was exactly what I was going to ask. I was going to ask, is this really true in this README, or are you just lying so that we don't use your code?
I think it's not that true anymore. Like yeah. It was true at some point. Like when I wrote it, it was true. The README is just outdated.
All right. Raj, you got anything else?
Nope. That's all from me. And this has been really helpful. Thanks, Eric, and spending the time with us. And
yeah, thanks for attending.
Looking forward to hacking to Minimint with Lloyd and others and see what we can find.
Yeah, like Lloyd, you have some background in cryptography. Like it would be really cool to chat about the BLS threshold blind signature stuff at some point, because I think you're maintaining this repository with all these Bitcoin research topics. Was it you?
Mm-hmm. Yes, that's me. And we have one about the variable amounts.
Yeah. And we could even add the second one eventually, actually sooner than later. Yep. Because it would be really useful to have a threshold partially blind signature scheme where I can commit to some data which isn't blind. Because eventually we want to, like, first of all, it could be used for different denominations, but right now we can just use different keys for that. That works. Mm-hmm. But if we wanted to have like dynamic assets, like for example, if we wanted to introduce like USDT or something like that, it would be annoying to always having to generate like new keys for that. Mm-hmm. So that might be a way to, instead have like a partially blind signature scheme.
Right. So you want an anonymous credential scheme instead of a blind signature scheme, which is
exactly
the classic problem. But I mean, the sort of good news is that the way it looks like you replace blind signatures with this like denomination, I guess ranges, or what do you call it? Fragmented denominations to make up change denominations. The way you replace that is by doing anonymous credentials scheme.
Yeah.
Okay. So you could do it both at the same time. So you would be like, have an authenticated credential, that would have whatever amount in it, right? There could be any Satoshi amount or even sub-Satoshi amount, and it would be sort of proved via Peterson commitment that the inputs get to the outputs, right? In your scheme via bulletproofs or some other proof system. And the one I would be looking at is similar to the Wasabi 2 one, which is the Wabi-Sabi. This is, I think, the right model in my mind, the research I've done so far. And so you would take this and you can add as many credentials as you want in that commitment and just make proofs about them and whatever. And so you could have different types of assets as well. No problem, I think, as long as you can verify you
that would be really cool.
So this would be, I was actually thinking of doing this in the week we have in the hackathon to sort of have a cryptography track. The way we actually tackled this problem, but we decided, I decided, no, let's just hack Rust code and not read cryptographic papers. So they're all going at the same speed. But this is something I want to get on very much soon.
That would be awesome.
I'm looking to put a team together to tackle this problem.
Yeah, because like my cryptographic background is limited. Like I understand a bit of that stuff, and like I designed this threshold blind signature scheme together with Jim Ruffing. But in the end, like I'm more of a like applied cryptographer, I'd say. I don't know. I wouldn't call myself a cryptographer at all, but like I just build cool protocols with that.
I'm very impressed with your code and your design so far. I really impressed. Like I didn't my head. The Mint code was more messy and more difficult to to come to figure out the state, I guess, of affairs with respect to deposits and stuff. But this transaction model has really impressed me. So it's much nicer than I had in my mind. So great job. And I'm planning to work on the cryptography side of things. I also, just to mention it, I'm working on this concept called payment hubs, which is something maybe you've heard of, like Tumblebit. And is A2L. So this is something like a non-custodial version of Minimint, but with some asterisks, right? And I think that there are some protocols that have in the works that are much better than the existing protocols for doing this and make it actually practical to do it. The thing is that I realized that you cannot actually do it without having a Mint protocol as well. Because with this payment hub protocol, you can do variable amounts as well, but you do need a single denomination. Like you need to cut it off somewhere, like at 1 million sats. The computation gets crazy if you need to do like, if you're depositing 10 Bitcoin, then that's 1,000 of these sort of commitments and proofs that you need to do, which can be done efficiently. But if it gets too big, then you can't do it efficiently, and then you have to either like make multiple denominations, sort of like you're doing now. I'm not satisfied with that solution, so I was thinking that under 1 million sats, the correct way to do a payment hub is just to do a mint, right? So small denominations, small payments, you just like just use the custodial version. But then if you want to do the send 1 Bitcoin or more, you can use the non-custodial version, which requires the receiver to do a protocol as well, right? So it requires not as flexible as the mint, but I think you need to do both. And I think the right way to do it is to start with the Mint, get the Mint model great. And then once it's like, mints seem to be custodying a bit too much money, then the payment hub protocol can be developed to take the larger payments off the actual balance sheet of the Mint. So that's my research.
I feel like you could already do that. You just need to change the client such that it waits deposits some money and then waits for a bit, and then only over time withdraws it again, because otherwise you have timing correlation. But as it is, it should already work for that use case, I feel.
But you already have, you would still have custody of it, right?
Right. In the current, yeah. I think when you're talking about the Mint, you meant a custodial scheme. Did you?
When I'm talking about a payment hub, I mean non-custodial, like totally non-custodial.
Okay.
But yeah.
Even for the Mint version. Okay, I'm not.
So a payment hub is a bit like a Mint, except that instead of having the incoming transaction go in, and then you get some tokens, and then you withdraw them, Okay, the outgoing transaction goes first. Okay, and you get like an invoice from that, but it's like a blinded invoice, let's say, randomized, and then you can go and pay for the invoice to unlock the coins.
Oh, okay. Okay.
But when you pay for the invoice, you cannot link it to the outgoing one. Okay?
Interesting.
So this is what Tumblebit and these kind of things try to achieve, but it's quite inefficient.
Yeah.
The cryptography is just inefficient, and it has the denomination problem. But you can get rid of the denomination problem and sort of do it for arbitrary amounts, as long as you have a single denomination, right? So like multiples of 1,000,000 sats, for example.
Yeah.
But then you still need a way of dealing with smaller amounts. And so that's my research agenda where
yeah, it sounds really
pushing
interesting.
But I think getting Minimint working as best we can is like what I'm looking to do right now. So yeah, we're gonna be doing our best over this week, and it'll be a lot of fun, I think.
Cool. Yeah, and thanks again for having me on, and wish you lots of fun at the hackathon.
Thank you very much.
Yeah.
Thanks,
Bye.
Thanks very much.
Thanks.
Thanks, guys.
Bye.
Thanks, guys. All right, see you next time. Bye.